This video we're going to focus on a factoring pattern called factoring by grouping. It's one of my favorite factoring methods, as a matter of fact. I can't explain why, I just like to do it, but I will say this. When we talk about factoring by grouping, it's called grouping because we're going to do exactly that. We're going to group some terms together at first. But essentially what I want you to know is this. It is often, let's see if I can write on top of this here, it is often used when you have 4 terms in your polynomial. So often applicable, let's put it that way. Often applies to 4-term polynomial situations. We'll just go ahead and scribble that down here. And so that would be kind of your cue when you see a 4-term polynomial here. Maybe factoring by grouping works. But the way this works is, our first step is we're going to group, the first and last 2 terms together. And that'll be the first thing we always do, and that's where it gets its name. So what we have here is this initial polynomial, and what I want to tell you is this. Always rewrite this. Sometimes I get lazy and I group this way, and this is what we're going to do here, but that's really lazy because I have to keep this negative with my 9 when we group here. So when I rewrite this, here's what the name grouping, how it gets applied in this instance here. We're going to group the first 2 terms. I'm going to put a plus sign here, always a plus sign. And then I'm going to keep that negative with my negative 9x there plus 18. And so our first step here with grouping is just to group the first 2 and the last 2 terms. What our next step is going to be is this, extract, we'll put it that way, extract the GCF from each set of parentheses, And you'll see what happens here when we do this. When I take out the GCF just from these first 2 terms, they both have in common an x squared. So if we take that out, I get left with this. I get left with x minus 2. And what I want you to see is this. So this is now x squared times x minus 2. That right there has an x minus 2 in it. When we look over here and we say, what can I factor out of this? What I want to do is factor something out of this that would leave behind an x minus 2. And so I notice that if I take out not just any 9, but a negative 9, I get left with this, a positive x minus a negative, well, minus a 2 right there. And so now I have this times this plus this times this. I should put my 9 and pink also there. But these both have in common an x minus 2. So what's going to happen is we're going to say because they both have in common an x minus 2, we're going to take that x minus 2 out in front now. And what I'm left with is that x squared minus 9 that would be left over. After we take out the x minus 2, we'd be left with these terms here. And those are represented with this factor. So we can check this. I do want to check this. If I FOIL this back out, I get x cubed minus 9x minus 2x squared plus 18. And writing this in standard form, we get x cubed minus 2x squared minus 9x plus 18, which is the same polynomial that we started with up here. So one thing I do want to mention here is this. It's not that you get this, is that we're not completely done with this polynomial. The fact is, this right here we recognize is a difference of 2 squares. So we're going to write equals again. Keeping the x minus 2 out in front, we're going to factor this into its conjugate pairs, x plus 3, x minus 3. And so we would say that because these are all unfactorable, this is the completely factored form. And we accomplish this by factoring by grouping, and we recognize this because it had 4 terms. Cheers.